Hello, everyone. This is the last session for the day. We'll have 3 talks. Yeah, so everybody having a good time? Good. Awesome. So yeah, we have, I guess last time is kind of veterans of BazelCon, some of them at least. So for the first talk, I welcome Case and Dave from Lyft. They will be talking about iOS development with Bazel.
Hey everyone, thanks for coming. So today, my colleague Dave Lee and me, Keith Smiley, are going to talk about our experience migrating Lyft's iOS code base to build with Bazel. So for some context on Lyft, we have a pretty large iOS team, decent amount of developers like all contributing to the same code base. You know, we have a few different apps and we share a lot of code between them, but in general, a lot of engineers working on that. There's just 2 of us, Dave and myself, working on tooling for this. Tooling is a little bit more than just the build, but that kind of gives you a sense of like resourcing for that. We have a decent amount of code. One interesting thing for iOS engineers is that we don't have any Objective-C, which is kind of unique. And all said and done, like today, we have a bunch of Bazel targets. So I want to briefly cover why we wanted to switch in the first place. So this is BazelCon, so I assume a lot of you have a positive impression of Bazel, so I'm not going to spend too much time on it. But I want to cover like the highlights that really led us to make that decision. So first off, whether or not you're familiar with like the iOS ecosystem isn't a huge deal, but you could do a whole talk on this piece. But the gist of it is that the state of iOS tooling, like out of the box, once you're working on larger projects with a larger team, doesn't really work very well, and it doesn't have a lot of answers to the common problems, like my app takes 45 minutes to build or whatever. And the key piece is really that it's not extensible. It's like a black box. It's closed source from Apple. You can't really add anything if you really wanted to. So that's one big piece, and kind of like Bazel is the opposite of that, right? Like we have this open, flexible ecosystem where we can contribute things back for other people, or if it doesn't make sense for everyone, we can still write our own rules and do lots of cool stuff there. So that's a really nice benefit for us. Another thing that not everyone's talked about is just like sharing tooling across more teams. So Lyft has a large iOS team, like I said, but we also have a large Android team, and we have a large server team, and a lot of people hit the same kind of problems. And what we found is we have like 3 or 4 infrastructure teams all kind of working on the exact same problems in different tool chains. So really, like if we could share some sort of tooling and infrastructure and knowledge, we get some benefit from that as a company as a whole, which is really nice. And that's something that obviously we're never going to get from like the core iOS tooling. And then of course, you know, some of the flashy features from Bazel, like remote caching and execution, are huge for us. You know, build times have increased a lot. We have a lot of code. About half of that code was written in the last 6 months, so we're increasing very quickly. And really, there's no solution in the iOS world to build times besides some big change like this. And especially in our code base where we kind of modularize, so developers only work on a specific section of code, but every time they pull, that kind of like invalidates the whole build graph. That pretty much meant that, you know, if they ever wanted to switch branches, they're like doing a clean build. So being able to use remote caching kind of like eliminates this for us entirely, which is great. So those are some of the highlights. You know, we could talk about that more after the talk if you're interested. And I want to kind of go through the process of how we migrated. So, you know, there was a talk that covered this a little bit this morning as well. Our steps are maybe a little bit more iOS specific, but of course your mileage may vary depending on the size of your company and what's going on there. So the first big thing for the iOS side is that, like I said, or kind of alluded to, like the standard tooling really doesn't work once you're working on a large team. And a big piece of this is like having your entire build configuration locked in this like closed binary undocumented format. So we took a few steps to get out of this. Like we kind of pulled all the settings we possibly could out, which is may not sound like a lot, but in the Xcode world, there's like thousands of settings. You have no idea what they do. You don't know how they affect your build or if they apply to it at all. So being able to like remove those and then reduce them as much as you can so you get an understanding of like what is my build even doing and like what flags do I even rely on was a huge win for us. And then the next piece was actually like just getting rid of this file, stop checking it in, start generating it from some other thing. There's a bunch of great tools out there to do that. But that gives us like a more clear path to move towards like build files as our source of truth. And actually, like the tools we wrote at this step to generate this project eventually helped us end up generating our build files, which was kind of one of the steps mentioned before at Wix, which is a really nice win for us because we had a bunch of modules. So handwriting all of that would have been a pain. The next big step that we took was just kind of like reining in what our build did. Of course, there are parameters on this. Like you can't remove all the features of your build, but there's plenty of stuff where maybe you don't need to be doing it that way, or like you could simplify it and bring some consistency to your code base. And I think this has wins outside of making it easier to switch build systems. For us, this also means that developers look between different modules, and they're all built exactly the same way. They don't have to go and see like how different is this, or is this going to build in a really different way, and I need to account for that somehow. It's just every single module they move between and they work on, like they all kind of look the same. And this directly translates to how much work do we need to put in like understanding Bazel rules, because we're just like kind of eliminating entire rules that we needed to support. The other thing that we did at this step was remove a bunch of third parties. Obviously, you might have limited flexibility there too, but we either removed them or we kind of pre-compiled them. So we kind of gave them to Bazel as one thing that looked the same no matter how they were produced, which means we could defer converting them to build with Bazel, which was a nice time saver too. So this was mentioned a few times today. This might be controversial, but for us, having a monorepo is actually not a true monorepo like Google. It's more of like an iOS monorepo, but that is where we are, and all of our iOS code lives there, similar for Android. Again, I don't think this is really Bazel specific. You get a lot of nice code sharing benefits, especially if you're like us, where we're shipping multiple apps and we want to share a lot of code between multiple apps. That's a nice win. But then this also matters once you start adding custom rules and custom macros. Either you're going to start maintaining different Bazel workspaces across a bunch of repos for CI or something, or you're going to end up having to do something like this. And I think this is the better path, but I'm happy to like have a holy war about this later if anyone's interested. So far, nothing I've said is like specific to Bazel, but I think those are all good things to do, even if you're not considering Bazel yet on like an iOS project. But once you kind of get into it, I think there's a few things that we did, a few specific things that were nice. So one was just trying to like ramp up with Bazel in the first place. So I think that Bazel has a decently high learning curve. I mean, it's a complex tool. It does a lot of great stuff, but you kind of need to spend some time like figuring out, how do I debug this? Like, what is the surface area of Bazel that I need to understand for my project? And for us, this actually meant converting this like protobuf generation pipeline to use Bazel for iOS so that we could get this understanding, but also not impact developer experience at all. So at this point, like this was an entirely automated thing. It kind of like vendored an artifact at the end that developers used, but they had no awareness that we were building with Bazel, which meant that we could introduce it and get all this experience without having to like also ramp up developers on like, here's how build files work and all this stuff, which we could kind of defer till later, which is really nice. The next kind of big step we did after that was like actually prototyping our build. So this was mentioned earlier in the talk from the BMW folks, but just trying to get a sense of like, what are the issues, what is the scope of like moving to Bazel? So for us, this meant like building our more complex app and just trying to like see where are the places where we may need to change stuff to make it work in a way that works for Bazel, and where are places where maybe we need to contribute something back to Bazel to work in a way that makes sense for a Swift app or whatever. I think this was the first time we really had a sense of like, how big is the scope of moving to Bazel actually going to be for our project. So of course, I've talked about a lot of time so far, but the next kind of step for us was actually like contributing back a bunch of these fixes to the rules or to the core Bazel pieces that kind of interact with the iOS stuff. And then we kind of spent some time like abstracting away some of the things that we didn't want to be in developers' faces. So on the iOS side, this meant kind of abstracting things that make sense in Bazel, but not for people coming from this Xcode background. So specifically, like Bazel has this divide between like library and packaging targets, and Xcode doesn't really have that, and we didn't really think it was valuable to kind of expose that to developers long term. So we kind of like made a higher level macro around these things to make it a little bit more like approachable for iOS engineers. But regardless of like how you decide to abstract that, I think there's a lot of work here of like rules you have to write or macros or whatever that you're going to have to spend a decent amount of time on to like actually get everything close to working for real. So Dave is going to spend the second half of this talk like talking more about what we went through to make this work well in the IDE. But we decided at this point that we didn't want to like fully migrate to Bazel locally in the IDE for developers, and it's just because integrating with Xcode is pretty difficult. So we decided to like generate a project from Bazel as the source of truth, but still building with Xcode, which is a nice like stepping stone, and I think it's kind of required given how much work it is to make it work in IDE right now. So we kind of were able to punt on that, but still have Bazel being the only source of truth for our builds, which is really nice. So of course, before we ship something to all of our engineers, we want to document it some. I think this, we had to do this for a few reasons. I think one is there is a lot of documentation out there about Bazel stuff, but it's a lot of like raw documentation. I don't really think we'd want to throw iOS engineers at like, here is the core documentation for all the rules, like have fun. So we spent a decent amount of time like documenting our API for our macros and stuff, and then some brief Bazel usage if people really wanted to use it. But realistically, most people were still kind of like just running the same kind of abstract command, and they weren't interacting with Bazel directly. And that was the kind of those were like the biggest steps we took. So obviously that would took like multiple months, but that was the biggest piece. Those were the biggest pieces. But of course at this point we weren't really done. We had a lot more work to do. The IDE piece that Dave's going to talk about was a huge amount of that. At this point we still hadn't like set up a remote cache or anything. And there's also like a lot of other low-hanging fruit that we can improve in our build to like just improve developer experience in general, which is actually really exciting. So I want to talk through a little bit about like what went well for our migration, and then a little bit about what didn't go so well. So first off, iterating with Starlark, we've heard a little bit about Starlark and like moving some of this native stuff out. And overall, like this is one of the most positive things, I think, in the way the iOS rules are currently set up. So if you're not familiar with the iOS rules, there's a few different repos, but they're almost entirely in Starlark, except for some shared stuff that lives in the native code. If you're exclusively Swift like we are, you have to deal less with the native stuff, which is nice. But working with Starlark rules sets is like much nicer. I think it's much more approachable if you don't come from a Java background, which I do not. But also there's some really cool tools for being able to like point at a local checkout while you're working on something, or apply some patches in your workspace while you're waiting on a PR to be merged that like helps really speed up like applying new fixes without having to wait for a full new Bazel release, which is really great. And the other thing that we heard a little bit about with the Bazel Federation talk is like the release cycle is flexible for better or worse. And for us, this meant that we would submit a bunch of fixes to rules repos, and they would merge, and we would just update to like the newest head of those repos. And of course, there's some risk with that, but it also has the added benefit of like we could move really fast as we were submitting new patches and reduce the risk of updates each time, which is really great. Another thing that worked really well for us, I kind of alluded to this, but reducing what we could do and like what we had to do to move really saved us a bunch of time. And just in general, the simplification. I mean, this totally makes sense, of course, and you may or may not be able to simplify as much as we did, but that really saved us a bunch of time because we could just totally ignore parts of Bazel that we just don't even have to deal with yet. And we may have to eventually, but in the meantime, we have like Bazel working, which is really nice because we started to see some of the benefits. Another thing that hasn't been talked about as much during this BazelCon, but was a lot last year, is forking. So we've decided, and like continue to decide, to never fork Bazel or any of the rules repos, which has advantages and disadvantages. I'd say that the reasons we decided to do this there are a few primary ones. So one is that the community is moving really fast, and at some point you're going to have to update. In the iOS community, it's probably going to be because Xcode releases a new version, and there need to be some rules changes related to it. And to update the rules, you may have to update Bazel because they're kind of tied to what's in Bazel core. So if you're going to fork, you're kind of committing to a long-term maintenance cost of this. I think the other part from the community perspective is that we're really interested in like investing in the community so that we can bring down the cost of adoption for everyone else, so that more iOS teams can move on to Bazel, and then we can kind of all solve the same problems around the same tool, which is like the first big time we've been able to do this with such a big tool in the iOS community, which is really great. But if those don't work for you, you can think of like, if you merge your changes upstream instead of just keeping them locally in a fork, you're getting integration testing from other companies, which is probably nice. So kind of related to that, we've also chose to like always stay super up to date. And this means like testing release candidates, updating Bazel like immediately after it's released, and like updating rules weekly. And again, the reasons are kind of related. Like the community is moving really fast. You're going to have to update at some point. The longer you wait, the more difficult that's going to be. You may think that like by staying on 1.0, you'll be able to avoid some breaking changes, or maybe you only update to 1.1, but realistically, there might be unintentional breaking changes, so like that's not going to save you a bunch. At some point, you're going to have to update, and you don't want it to be in like a mad rush where it's like, oh man, we found this bug in our build, and now we really have to update today, otherwise, we're totally screwed. And of course, the biggest reason maybe you'd say to not do this is that you want other people to find your bugs first. And that could work. I guess my counter argument to that is that Bazel is a really complex tool with a really large surface area, and we're all using it in slightly different ways. So I'm not actually sure that by waiting another month for us not updating, like our specific bug will be discovered and fixed by the time that we would actually update. So I kind of think it gives you this like false sense of security that like, oh, I waited a month, so now it's totally stable. When in reality, it's just like, well, no one's using it the exact same way you are. So we've decided to do this, and I think this has worked pretty well for us. So the last thing that I want to mention about this is just generally keeping up with the community. So this may seem like a lot of work because there's a lot of stuff happening in the Bazel community, and you hear from a lot of people like, oh, stuff is changing so fast, and that makes it hard to update and stuff. But I actually think this is kind of a huge advantage. And coming from this iOS background where you can't keep up with the community around the build because this is all just closed source stuff that you can't actually pay attention to or have any input on, this is like an entirely different thing where I can subscribe to the commits RSS feed and see everything coming down the pipe for what's happening in Bazel or what's happening in the rules, which is super powerful. And then we end up not being surprised by changes when they actually ship, which is really great, or see great features coming down the pipe ahead of time. Also, this like helps us identify what other people in the community are interested in and maybe try to collaborate with them on something that they're working on that we're also interested in, which is really cool. So all tools have trade-offs, so I want to talk about some of the things that didn't go as well for us, but I have a disclaimer that Bazel's really great. I think if we hadn't migrated, like our developer experience would be much worse than it is today, and I don't think we would have any clear path towards improving it because of the tools that Apple provides us. But I want to talk about a few of the things that kind of like hurt us the most during the migration and possibly still today. So first off, I think that the adoption cost is super high. So I mean, there's the kind of unsurprising cost of, it's a complex tool, you have to learn about it. There's definitely that. Dave, like I said a few times, we'll talk about the IDE piece, which is probably the highest cost for us. And I do think that, the larger your project is, the more scope you might have to support, and then the more rules you depend on, and then the more issues you find as you try to migrate to them. So there's definitely like a possible scope creep there that could increase this even more. I think a big piece of this in the iOS community is that Bazel is written by Google with the way that Google works on things, which is very different, I think, from how a lot of like more standard iOS companies work, or just companies who don't ship hundreds of apps with like thousands of engineers. And so I think very quickly when you start adopting Bazel, you kind of hit some wall where you're kind of surprised because you're like, wow, I really expected it would have supported this. Like in the Objective-C land, this is like not supporting header maps, and in the Swift land, maybe it's like your imports are based on the directory structure of your source code, which is just something like iOS engineers really don't expect. So you end up hitting something like this that causes you to either change your own code or find a workaround or contribute it back to Bazel or something, but all of those things can end up taking a decent amount of your time. Another thing that's been talked about a few times this morning is just transitive dependency management in the workspace is really difficult. I think the big surprising piece here for us was that we didn't expect to end up depending on like almost all public rule sets, but that's kind of been the reality. Because once you depend on a few rule sets, like the iOS ones, and then maybe you pull in a tool like Build-A-Fire that's written in Go, and you have these, you kind of just end up with everything. And at that point, you really do have to be careful about, oh, this specific version of Skylib or whatever is transitively incompatible. And we've actually been blocked by that specific issue from updating the rules before. So you have to kind of be careful about this. Obviously, this is what the Bazel Federation is designed to solve, so I really am excited about that in the future. Like I said earlier, this kind of worked well for us, but I also think that staying up to date is really required right now. Again, you're going to have to update at some point. So if we agree on that, then the next piece is that kind of everything is intertwined. So if you update rules, you're going to have to update Bazel and vice versa. At some point, you're going to. So we've found that the best way to do this is to kind of treat our project more like a monorepo, where with most rules repos, we assume head, and then we assume the newest Bazel version, and that works well for us. And this makes sense because this is obviously what Google's doing here. But the worst case scenario that I'm sure many of you have heard of here is that you can end up being stuck behind, like one team at Lyft who is stuck behind because of a version of protobuf and some transitive dependency conflicts, and that makes it really tough for them to update, and now they're like a year behind on Bazel versions, which is really unfortunate. So another thing we were kind of surprised by, Hermiticity is this core really great feature of Bazel that really separates it from how it works in Xcode and really enables some of these great features. But we've been surprised with kind of like how brittle this has been for us. And there's a few problems with that. I mean, one is just that it can kind of happen anywhere in the stack. So like any piece of Bazel can break this. It can be the rules or like Bazel core stuff or just kind of anywhere. And then the problem that you get hit with when this happens is that you totally break remote caching. And for us, that means like totally destroying build times. And so we've had to do a few things to like make sure this isn't the case. Like we wrap everyone's Bazel invocations and make sure the paths are identical, because otherwise you definitely will never get a cache hit and stuff like that. But you have to be really careful, I think, to make sure you don't break these. And especially if you do, you end up having to spend a lot of time like trying to debug, see, I built this, locally I built this, like where did the first problem show up, which can also be pretty hard to do. And lastly, I feel like since this is an iOS talk, I have to mention this. So right now in the Bazel community, like unfortunately, iOS is a little bit of a second-class citizen. I think some of this is just because historically there haven't been a lot of companies who want to make a big move like this to another build tool. And I think this is something that can really change over time, especially as many of you like decide that moving to Bazel is the right choice. But right now, this kind of hits you with different issues. Some like fix will get merged for a Linux thing that happens to break a macOS thing because of different assumptions about how this stuff works. Or we don't get support from services like Google RBE because it's a smaller market than the Linux side of things. So I'm hoping this will change more in the future, and I think it's improving already. But currently, I think this is still a little bit the state. And I have to leave on a positive note, so I stole this from Oscar's talk later. But I think that like overall, this was the experience of us migrating. But I think Bazel has a really bright future in the iOS community and in more communities too, but this is the one I'm particularly interested in. And I think that as we all continue to adopt Bazel and contribute back, we can really lower the costs for everyone to adopt Bazel in the future, which I think is better for all of us. So Dave is going to talk a little bit more about how he integrated Bazel into Xcode. Thanks.
Thanks, Keith.
Thanks.
Thanks, Keith. So I'm Dave. I work at Lyft as well. And as you can see, I'm going to talk about IDE integration, which for iOS, that means Xcode. We all talk here about builds. Everything is build, build, build. But when you're doing development, a lot of that activity is other things, and builds are kind of this secondary thing. Developers are writing code, designing things, and then there's this gap between they hit build and does my code actually work? So there's a lot of things that we had to make work in order to integrate Bazel while keeping in, like as much as possible, a native Xcode experience, and keeping the build, keeping Bazel an implementation detail. So right now, there are two options on the market for Xcode Bazel integration. There's Tulsi by Google, and then XChammer by Pinterest. XChammer makes use of Tulsi as well, so there's a bit of shared benefits going on there. And when we were trying to figure it out, we had a couple considerations to consider. We had the workflow our developers already have. We have conventions in our project and assumptions. And then there were a few other things. And we started with these, and while they might be great for getting started for us, the thing that they really provided was a third option, which was learning from them. And like Google and Pinterest, we made our own. So unlike Google and Pinterest, we're not necessarily going to open source it. We may. People ask us. We'll see what happens. But by taking on full maintenance of our own project generator, we buy an opportunity to have a tool that's custom made for our Lyft, for our repos, for our workflows, all of that. But the good news is that Bazel and the open source community in general provide all the building blocks to write your own project generator. And so for the rest of this, I'll kind of go into details about how you might do this. So we have a fairly modular project. Keith, I think, mentioned that. So every single pull, every single commit could change the build graph. It's dynamic. And so we can't have a static project. We need to generate it with every commit. So using some typed starlark, just kidding, that's Python. Our project is a function that takes Bazel in and puts an Xcode out. The Xcode file format is really messy. Many of you probably already know that. It's not easy to generate. It's not easy to code review or version control. And so because of this, there are open source tools that take a friendlier format like JSON and YAML and produce an Xcode project for you. So we use XcodeGen for this. Xcode Gen has been great for us, and we used it before Bazel, and then we continue to use it after we've adopted Bazel. OK, so how do we do this? How do you take Bazel as an input to a function? So you need to get that build graph into some usable data structure, a usable format. And there are a few options for this. Tulsi, and I saw a Visual Studio generator out there, use aspects. So you could do something like this. You write an aspect, it inspects your graph, and then writes out some file. And then you use that file to generate your project, basically getting the data out of build files instead of parsing the build files. And then there's Bazel query and Bazel C query. XML and Proto are some options there. And for us, we ended up going with Bazel query because, well, one, it was really fast and convenient, but also we don't have aspects in C query. Might be better if you've got a build graph that's like configurable, highly configurable. But we provide, as Keith mentioned, a build API that's simplified for developers. And in that build API, you don't have any select functions. So our build graph is fairly static, and that means we can use query like that and Bazel query and get all the data we need. We do use select in our build, but it's just an implementation detail. It's hidden from developers and hidden from the IDE. OK, so now that we know how to do the input, how do we get the output? So what we really want to see this as, or how I see this as, is that by default, an Xcode project is tightly integrated with its own build tool. And so there's the first option. And then the second option is decoupling it and having your Xcode project, but have it build with Bazel under the hood. So and Keith mentioned this as well, our incremental approach to adopting Bazel was get all of our build into a Bazel build files, and we could use that to be the source of truth, and take our Xcode project and take our Bazel build files and generate an Xcode project that builds with Xcode. So yeah, so this was how we did our incremental migration. Basically 2 parallel steps. And once we have that first step going, once we have the build in Bazel, we got the benefits of running it on CI. Meanwhile, we weren't blocked. We weren't stopped from adopting Bazel, and we could jump to using Xcode that builds with Xcode. So the next big step is going from XcodeBuild to BazelBuild. And this is where there was a lot of challenges, a lot of effort. This was a place where the adoption cost was really high. So making Xcode build with Bazel is 2 operations. One, make it build with Bazel, but also making it not build with XcodeBuild. OK, so first of all, let's figure out how we added Bazel into Xcode. Xcode has this thing called an external build system target. And you would think, like, hey, that's what I want, right? But I think it's some legacy thing. I don't think Apple cares about it. I don't know why they don't just remove it, because it's not what you'd want. It sounds right, but so Xcode has this other thing called a run script, and it's pretty obvious by the name. It allows you to attach a script to any target, and when you build that target, that script gets run. And it's available in all target types, your applications, unit tests, et cetera. And so from this run script, we can easily call BazelBuild. So just like that, we have Bazel building as a part of Xcode. And the benefit is that Xcode sees everything like as though it's normal, like we've tricked it. It doesn't know that we're doing another build necessarily. So it's not invasive surgery to do this. OK, so we've got Xcode building with Bazel. Now how do we run our apps or run the tests? So you take from your Bazel out directory, you take the app or the XC test, and you copy it to Xcode's derived data, which is its Bazel out. And that's it. Xcode does the rest. Once you put it there, it'll copy it wherever it needs to copy it and execute whatever it needs to execute. This gives you really great IDE integration. So shout out to Rules Apple, because they're the ones that produce the .app, the XC test, and it's been perfectly compatible. And this part was by far the easiest thing to do integrating Xcode with Bazel. But there are other steps that you have to do after you've built the app and copied in the app. So we install things. But Xcode also tries to do some other things that it thinks it needs to do and is surprised when certain files don't exist at certain locations. And so we have to satisfy Xcode by copying a very small amount of build artifacts from Bazel's out into derived data. And then supporting IDE features means importing a few other build outputs, and I'll get into those in a moment. And lastly, we have to generate debugger settings, and this is also a bigger piece that I'll get into in a moment. But all of these things, the way I look at it, the view I've taken is that after building with Bazel, we have this random, structured installer. So there's an installer that needs to be there. So this was like a guiding principle, and maybe Googlers know this one really well. This was how I made a lot of this work, was just see what Xcode does, treat that as public API, and copy it. That way, to Xcode, it's none the wiser. And this was a joke amongst us, but also a really useful way of looking at how to get the job done here. And Xcode's pretty tolerant to letting things like that happen. So now that we've added Bazel and we've got an installer going, now we've got two build systems. So if you hit build, you're building things twice, which obviously we don't want, so we're not done. So we have to disable XcodeBuild. Now, as I mentioned, Tulsi and XChammer provide a really great starting point for getting started with Bazel and for us to learn how to do this kind of thing. And both Tulsi and Bazel use run scripts like I showed there. But Tulsi and XChammer do a different way for disabling XcodeBuild, and we followed that way for a while. But it didn't really achieve the parity and the sort of simplicity that we wanted with Xcode, with a native Xcode experience for developers. So fast forward a few months of doing it the other way, and we came to this solution. Yeah. When I look back on this, it's I feel so stupid. Now, if you've done any make, setting these variables as make environment variables seems maybe obvious to do. But what these are XcodeBuild settings. So they're not make environment variables. And so I guess the idea of an XcodeBuild setting and a make environment variable, those neurons just didn't connect. These things aren't documented. Using this approach, as far as I know, isn't really widely known or done very much, but it does the job. Yeah, and so just as a finishing part, this is something that makes me feel like it was good to build our own, because we got to a point which was much less complexity and gave a higher quality Xcode experience for developers. But it also can be customized. So we have a solution in the works where Clang and Swift, they can provide fix-its. If you've done something wrong, it can tell you here's the right way to do it, and that gets exposed in the Xcode user interface. And so the fix we have in the works means we have to pipe some output from the compiler back to the IDE, and because we are now the compiler, or we can hook ourselves in here, this is a great way to customize and get parity on Xcode features. Indexing. So indexing is this weird beast. I've heard some companies for Xcode and Android turn off indexing because for large projects it's ridiculously slow. And on the other end of the spectrum, I've heard of at least one developer mention that he'll wait until Xcode indexing is done before he'll start coding, because he wants all the indexing features. And indexing is a primary advantage of an IDE, right? Otherwise, we'd all be using Vim and Emacs. So we wanted to keep that. We wanted full indexing support. But it's slow sometimes, and it's usually proprietary or some sort of black box, not well understood. And it's often out of band. You open up your IDE and it starts indexing for you. But our integration, we saw an opportunity. So both Swift and Clang can produce indexes while building, which means we can mark them as outputs, action outputs, and Bazel can cache them. But the problem is there are absolute paths, and these absolute paths don't really matter much to the build. They're just an output. But for bringing them back into Xcode, we have to do something about that. But because Swift and Clang are open source and their component libraries are open source, we were able to make a tool. So we wrote a tool called index import, and basically all it does is it's like a sed, but for index files. And you have a command line, you say which paths you want to rewrite from Bazel paths to Xcode paths, and it copies the files and rewrites the paths. And we open source that. Okay, debugging. So debugging on iOS means LLDB. It gets a bit of a bad reputation, and I actually like LLDB a lot, but making debugging work with Bazel was by far the most painful and continues to be a pain for making it work. And so there's a bunch of reasons why, but the biggest main reason is paths. There are just so many different kinds of paths involved: source paths, binary paths, absolute paths, relative paths, paths that Xcode sees from your project, paths that the compiler saw because it was built in the sandbox. And the fix is to remove those paths altogether from the binary, or by making them relative. But even just doing this isn't easy. Removing paths maybe isn't always possible, as the case was with indexing. Sometimes a flag will remove a path, but it'll remove some other things, so there's side effects to that. And sometimes downstream tools don't handle relative paths, even if you succeed in doing that. So there was a lot of solutions to this. You have to use all the right compiler flags, which of course is a bit of a magic thing to figure out. And thankfully, Bazel and Rules Swift have support for this, using the right flags in certain cases. But you have to do linking locally because of the way debug info works and the way it's embedded in a binary. And then for us, one of the challenges was being able to have a debuggable local developer experience where the build was hitting the build cache. And the solution to this one was we had to disable some compiler flags from being embedded, but we needed one single module that we attached that had to be run locally, and that solved the problem. So all the rest of the stuff could come from cache, but this one little empty module brought in all the debugging info that we needed. And then there's a problem of where you generate LLDB settings, and then you have to figure out a way to hook that into the user's own settings. But finally, everything works, pretty much. So stepping back a bit, we are at a position where we're building with Bazel, which is powerful. We have customized project generation, and we've taken the build away from Xcode. So it doesn't know what a build is anymore. It doesn't have to worry about dependencies or any of that stuff. And so there's now this tradition a bit for big companies where you solve Xcode performance problems by generating a focused subproject. And so that was our next step. So basically what this means is, as a developer, you say, here are the modules and targets I want to work on. And because Xcode doesn't care if the dependencies are there, the transitive dependencies are there, you get a very small project with just what you've specified. None of the dependencies are required. So I could build Lyft without any of its dependencies by just specifying the Lyft app. And the benefits are, again, that things get faster. So generating a project is faster. A large project with all the dependencies is slow to load and slow to generate. Launching Xcode time is faster, and the time to usability is faster. To use like Bazel terminology, I think its configuration and analysis is really slow, and it doesn't have like a daemon that it can use and run. So every time you launch, it has to rerun that stuff every time. you get natural scopes for developers and teams. You don't have to have a whole project that everybody shares. You can have smaller projects. And the performance scales by whatever the developer's scope is, not by the way your repo is scaling. There were a few finer details that we wanted to make work with Xcode, and most of these, all of these either work or have a fix in progress. So Xcode has this ability to click a little green checkbox by a test function or a test class, and it'll run just that rather than running your whole test suite. We've got that. We augmented the project search so that even though you might have focused only on a couple modules, you could still search the whole repo. And because of the way we do indexing, you get the full advantage of the full index, not just the index of the modules you've added to the project. So I can do a refactor, an Xcode refactor, rename refactor, and it will find all of the files that are even not in the project and rename them. You can also find callers of functions that are outside of your project. And remote cache, we slid that right in. So because they were using Bazel, we turned it on and people started getting remote cache. There's a few unresolved issues. I'm not going to, in essence, because of time, I'm not going to go into it, but here they are. The biggest one for me, oops, I went too far. Can you go back one? Thanks. The biggest one, I think, for us is the Bazel and Swift parallelism mismatch. So, Bazel is a build system, and Swift-C thinks it's a build system. And there are times when Bazel is only running one thing, and it could be saying, hey, Swift-C, why don't you run more? But that just doesn't work. So sometimes Swift-C is kind of starved of having availability of full parallelism. So yeah, so with that, we're happy to take questions, and come talk to us if you want any advice with iOS migration. Thank you.
Right, thanks for the great talk. Any questions on the mics?
Hey, I'm Steven from Airbnb. Dave, Keith, that was awesome. Thank you. I was just wondering if you could clarify how many times BuckBuild will get called. Is it once per library, or is it just once for your whole project? BazelBuild.
Yeah,
sorry,
yeah. That's good. You meant to do that, I'm sure. It's just the top level one. So when you say, you have a scheme, and that scheme dictates. So if you want to work on just a specific library, then you'll be on a scheme, and that scheme will call BazelBuild once. We call Bazel run for a bunch of things, but there's just one single build going on at any time, whether it's an app or a test.
Thanks.
Let's take a question from the top. Just one more.
Yeah.
Hi, Alex Niederberg from Capital One. Can you talk about your CI infrastructure that you use to execute Bazel commands?
Yeah, so we use like BuildKite on our own Mac Minis, if you're interested in that part. But we do some things around only building what changed based on doing like an RDEPS query with Bazel, which works really well. We've been doing it for a long time. We're actually doing that with our own tooling before we moved to Bazel as well. But we just have some, scripts that have some logic around, like, yeah, given this file set change, like what apps do I need to build and what test targets do I need to retest? Overall, I'm happy to talk about it more, but overall, it's like actually pretty simple. Like RDEPS does all the heavy lifting for us.
Thanks. I'll come find you later.
Cool.
All right, thank you very much.
Thank you.